During development, the human head comes together in the midline like a giant three-dimensional puzzle. The pieces of this puzzle include spaces for the nervous system, sensory organs, the airway, and the upper part of our digestive system. Our head is divided into different compartments. Some of these spaces need to communicate. Others need to be kept separate. A dynamic system of valves allows for the controlled communication and separation of some of these spaces. We can hold water in our mouths while breathing, but have you ever laughed just as you took a drink of water? Did that water come out of your nose? Let's have a look at how this system works to let us breathe and eat, and keep the two separate, most of the time.
This is a sketch of the head, the neck, and the openings to the thorax and upper limbs. Here is the cranial cavity, the two ears, and two orbits. These cavities are functionally related to each other. Information from the inner ear and the eye needs to reach the brain and the cranial cavity. While our ears are always open, we can open and close our eyes with our eyelids. A single oral cavity lies below the two nasal cavities, and the hard palate separates them. Each nasal cavity has an anterior opening, the nostril or nares, and a posterior opening, the choana. The nasal cavities, nostrils, and choanae are always open.
Let's look at this hemisection through the head to fully appreciate the extent of the nasal cavity. The nostrils are here. This is the position of the choana. The lateral wall of the nasal cavity has these projections, called turbinates, that increase the surface area. This is important to humidify and warm the air and to capture particulates. This is the hard palate. It separates the nasal cavity from the oral cavity.
Here's a representation of the oral cavity. It has an anterior opening, the oral fissure, between the lips, and a posterior opening, the oropharyngeal isthmus.
In this hemisection of the head, you can see all the defining features of the oral cavity. Here is the oral fissure between the lips. The palatoglossal fold here is the landmark for the lateral boundary of the oropharyngeal isthmus. The mylohyoid muscle here is the landmark for the floor of the oral cavity.
The neck provides mobility and support for the head. It also provides the conduits for air, food, blood vessels, and the nervous system. Let's consider the pathways of air and food. The oral and nasal cavities are joined together posteriorly by the pharynx, this musculofascial half-cylinder. The pharynx is attached above to the skull, below to the esophagus, and anteriorly to the lateral walls of the nasal cavities, oral cavity, and larynx. Although this is a continuous structure, it can be divided into three parts: the nasopharynx, the oropharynx, and the laryngopharynx. Let's look at the pathway air would take to the lungs. Air typically enters the nasal cavities and travels through the entire pharynx and passes anteriorly into the larynx. Here is the opening to the larynx. You can see that it opens posteriorly towards the laryngopharynx, and it sits right under the oropharyngeal isthmus. Food, on the other hand, enters the oral cavity, where it is chewed and then swallowed, a process that propels the bolus of food posteriorly through the oropharynx to the esophagus, which is positioned posterior to the trachea. As you can see, we have a problem. The pathways for food and air share common spaces, and they cross. We're now going to talk about the three major valves that ensure that food and air enter the appropriate tubes without interfering with each other. The first of these valves is the soft palate. It is attached to the posterior edge of the hard palate. It can elevate to close off the nasopharynx from the oropharynx, or it can depress to close the oropharyngeal isthmus. In this position, the oral cavity is completely isolated from the rest of the system.
This explains why you can hold food or liquid in your mouth and breathe at the same time.
The second valve is the epiglottis. This is a cartilage that forms this sloping roof of the larynx. It's hinged at the front and moves up and down to open and close the superior aperture of the larynx. The third valve is formed mainly by the vocal folds. They are located within the larynx itself. You can see how the vocal folds come together in the midline and completely occlude the airway. Let's have a look at these valves in the lab.
We can review the three valves on these specimens. Here is the soft palate. It can swing up to isolate the nasal cavity, or it can swing down to isolate the oral cavity. This is the sloping roof of the epiglottis. It can pull down to isolate the airway. Let's have a closer look at the larynx. This specimen has been opened up from posterior. Here is the epiglottis. And when you look down, you can see the vocal folds here. They can move towards the midline to fully seal off the airway. Let's have a look at how these valves and other soft tissue features work dynamically during swallowing in this upper GI study.
In this fluoroscopy study, you can see the nasal cavities, oral cavity, pharynx, larynx, trachea, and esophagus. You can also see the three major valves that separate the digestive from the respiratory tract. Here is the soft palate, the epiglottis, and the approximate position of the vocal folds. The soft palate is swung down in this still image, and together with elevation of the back of the tongue, completely closes the oropharyngeal isthmus and separates the oral cavity from the airway. The airway is completely open here so that this person is breathing while holding food in the oral cavity. As the person swallows, the soft palate elevates to open the oropharyngeal isthmus. At the same time, the epiglottis closes the opening to the larynx, and the vocal folds and other soft tissues in the larynx completely seal the laryngeal cavity. Also notice that the larynx moves up and forward. This not only assists in moving the epiglottis down to close the superior opening of the larynx, it pulls the esophagus open so that food passes into the digestive tract.
You can see that the puzzle pieces that make up the head communicate and move dynamically to allow for basic processes such as breathing and swallowing. A system of valves allows both air and food to share the same spaces, an efficient way to reconcile these diverse functions in a small space. Usually, these spaces are kept separate, but sometimes they can interfere with each other. We can choke on our food, or we have liquid coming out of our nose.
It just started dripping out of my nose randomly. I'm like, burning. burning. I did it once with milk on my brother. He's very annoying.
It hurt a lot because it like stinged.
Yeah, it was very unexpected. It kind of felt a bit hot. Maybe like that much. I guess it was kind of the distance between you and me, but there was like a table and it just kind of just went everywhere. The people in front of me got really wet. It was really gross.